Okay, it's Tuesday, it's 1 o'clock. We're back with our next HDF clinic. Today, we have a little bit of an experimental setup. I don't know, it's not really important, but you might see a little bit of a contraption in front of me here. It's a new microphone, and we wanted to try if that can help to improve the audio quality on the YouTube videos and so forth. So we'll see how that goes. And probably in the middle of the meeting, I will make a gesture and then just rip out the cable or something like that. But yeah, we'll see. Okay, first things first, I think I took a quick look earlier. There weren't any questions. No, there aren't any on the on our Google Sheet. That's okay. We have other stuff to talk about. But maybe sort of before I jump into it, for those of you who are here today, do you have any questions? Anything you would like to talk about now or later, or speak up? And I'll ask that question many more times. So if not now, you can come in later. Okay, good. Well, let's just jump right in. I haven't done my homework, so I'm a bad student. There are still 2 open questions that I've been sitting on. It's just a matter of talking to one of my colleagues and well, talking these days in COVID days, sending them an email or by accident being in the same meeting and then saying, hey, do you remember what about this? And that hasn't happened. And but we'll get there. So I'll get you answers to these questions. Let's start talking about last week's highlights. Number 1, well, those 2 were here last week. I just want to remind everybody that we will have a webinar on Hermes on December 1st at 11 o'clock Central. The link for the registration is here. So I encourage you, if you are interested, come and join us. And we actually had the release, the 010 beta release of Hermes last week. And there is a very nice getting started guide that my colleague Chris Hogan put together. Here's the link to GitHub. So if you just before the event want to look around a little bit, feel free, or I encourage you to do that. The other one was, still the Swimmer VFD Beta is open and will be closing sooner or later. I put here the links to the forum posts and to the GitHub repo, to the branch, and that team really would like feedback and before they wrap it up and call it a release. And then there might still be issues, but it's going to be what it's going to be at that point. Before I jump to the forum, any other questions so far? Does anybody have any questions, comments about this or your application? That's the most important thing, your use of HDF5. If you have anything, feel free to speak up. No? Okay. Then let's just press on. There were several interesting posts, as always, on the forum. I'll start with this one. It was actually the one that talked about the Swimmer VFD Beta. And just when I went through it this morning, somebody left a comment there asking whether VFD Swimmer Beta would be part of HDF 5.1.1.3. And interestingly enough, initially I thought, sure, but then I sort of I started thinking about it, and so it's one of these curious situations where it's this yes and no answer, or no and yes in this case. In the sense, it depends on what you mean by is Swimmer VFD Beta part of HDF 5.1.1.3. And what I mean by that is in HDF 5.1.1.3, we implemented or we introduce this new, it's an API, it's an API, a new API for the virtual file layer, or VFL. And what it allows you to do is to load VFL plugins, or we call them VFDs, virtual file drivers. So file drivers, they implement this virtual file layer interface, and we allow them to be dynamically loadable the same way that filter plugins, in particular compression plugins, have been dynamically loadable for the longest time. So of course, that capability then in a way shifts the meaning of is something part of a particular HDF5 library release, because what this opens up the possibility for is that you can historically, since the virtual file drivers that you were using in your applications, they had to be compiled into your instance of the HDF5 library. They had to be baked in, so to speak. But with dynamically loadable VFDs, that's no longer necessary. So when you, for example, would like to maintain a repo, a source code, or something like that, where you keep your development of that particular VFD, that's perfectly fine. When it comes time to create that shared library, or that DLL, then you just compile your VFD into that shared library with the HDF5 library that you may have in binary form, plus the header files like h5fd public.h or something like that. So it will depend on certain public headers of the HDF5 library, but that's it. So in that sense, VFDs become decoupled from the library, and the release cycle, if you wish, of VFDs also becomes decoupled from the library release cycle. And two such VFDs or library versions will be compatible as long as in the library that interface for the dynamical loading of VFDs doesn't change. That's fine. You will be able to use your VFD, or that VFD developed by your team, with the next library after that, and perfectly happily. So in that sense, the question of whether a VFD is part of the library in a sense evaporates. So in that sense, the answer is no, but the answer is yes, in the sense that the HDF5 library will now, in 1.13 for the first time, include this interface that makes it possible to load VFDs dynamically. And so if you want to interpret being part of the library, that capability being part of the library, if you want to interpret it as that, then yes. So VFD Swimmer, and I believe all the sort of recently or the currently under development VFDs such as Onion, GPU Direct, Swimmer, and so forth, I think they are all written so that they can be dynamically loaded. And so in that sense, yes, they will be compatible with that HDF5 1.13 release. And so that is in a way the yes part, or the yes aspect of the answer. So I don't know if you are now more confused than you were before, but so the good news is, yes, you can use Swimmer VFD with HDF5 1.13. And if you want to think about it in a traditional sense, could it be that the official release of HDF5 1.13, the date, coincides with the official release date for VFD Swimmer? that is very well possible, and that might give it the appearance that sort of VFD Swimmer is part of HDF 5.1.13, but again, that is only true in a very limited sense, because HDF 5.1.13 introduces this concept of that you can now, starting with that release, decouple VFDs and library releases. So I think that's progress, and it's really more. When we say these things, sometimes we have to think carefully about what we are saying, and if there is a shift in meaning, then we should just remind ourselves that that's occurring, and to avoid potential misunderstandings. Anyway, I'm just going to pause. Any questions? No? Okay, I'll just press on. Or yeah. The next post, that was something, there was a user, it appears he's working in Java, and he was using the, to create the H5T, the type API, to create a user-defined data type, and that's all great. And he had some issues there, but he had sort of a question about this type. There in the HDF5 library, we in a way categorize data types by things like, they are so-called atomic data types that includes the fixed size types such as integers and floating point and whatnot. And then there are compound types. Those are like records with fields and so forth. But then there's also this class of array types who are supposed to represent fixed size multidimensional arrays. And fixed size multidimensional arrays, a typical situation being that let's say you have a position or something that let's say mathematicians or even domain scientists would represent as a vector of some kind in a particular coordinate system or something. And if you would like to model that notion in HDF5, you could think about, rather than using three, like a matrix, depending on what kind of spatial structure you are interested in, a matrix with 3 columns or a matrix with 3 rows, let's say you're working in 3 dimensions, you could sort of bake that the fact that you are dealing with 3 dimensions into the data type. So you could create a 1-dimensional of length 3 array type, and then use that as the element type to define a data set of whatever dimensions you desire. And so he had just a clarifying question about what are these array types supposed to represent. And that's exactly that. Like, there are physical quantities that can be represented with just scalars, with just a single number. And then there are sort of multi, if you wish, number constructs, and such as vectors or tensors, multidimensional quantities. And that's what these array types are for. Now, as always, what I would like to point out is it's part of the marvels or the magic of HDF5 that you can recombine and use the existing system of built-in types and type generators, so to speak, to create new types. And that's a good thing. And however, depending on who your audience is, what the kinds of tools are the support of which you would like to count on, because you have users that use MATLAB or use Python or use R or something like that. I would be careful with not going too crazy with those types, because yeah, you can create very deeply nested things that aesthetically or otherwise might you think might represent very well what how domain scientists sort of think about these quantities and so forth. But that doesn't mean that in practice this will translate into a success story, because some of these tools support certain aspects of the type system, but not others. And so if you want to achieve the greatest breadth of support, the only thing I can say is, yeah, don't go crazy with those data types, and just keep it to a sort of middle of the road floating point number, standard floating point number types, 32-bit, 64-bit floating point numbers, integers. Most tools in the ecosystem, they can also handle array types, although maybe they can't handle exactly 32-dimensional fixed size arrays or something like that. So as tempting as that may sound, that's maybe not a good idea. So that's all I wanted to say here. I'm going to pause, see if there are any questions. Okay. Then there was a brief discussion about dynamically loaded filters on macOS, and yeah, it's not something I personally can say very much about because I'm not a macOS user, but I understand that over the years there was this evolution of sort of the shared library concept under macOS, and then with the introduction of new processor architectures, then these so-called universal binaries, and then conventions that Apple made about where, with respect to the executable, certain binary dependencies should be placed and so forth. And so if this is of concern to you, the user there was describing an issue with the inability of a tool to find one of these binary dependencies, and then, but he, I think he used it here. He used not ldconfig. I forgot. There is a tool. It's in the post. He described how he sort of trouble managed these. The lookup process and so forth, and then ultimately found where macOS is actually looking for what, and then yeah, make it discover the things that were there from the very beginning. It's just, yeah, maybe a little unexpected where the system was actually looking for these dependencies. So if that's a problem that you have, take a closer look at that post. Any other questions? No? Okay. Pressing on. This is another, I believe it was the same user, and it's great to see. That's part of, in a way, when I learned HDF5, yeah, you start playing with all the different options and choices and whatnot. And he also looked into variable length types, and something we talked about last time. And he, again, this is through the Java API. In a way, I feel sorry for the user, because, and this is not specific to Java, but I think Java is one of those problem children. And in the following sense, so he was struggling, and I got to take a closer look. I'm not a Java programmer myself, but I think I can, looking at his code, I can sort of figure out where he's going, and I can compare that with what our Java API looks like, and if there's a match to make it happen. But this is sort of a general source of joy, but also frustration of what I would call language bindings to the HDF5C API. So when you want to access HDF5 files, you have fundamentally two options. Number one is, yeah, you the language or the environment from which you would like to access these HDF5 files has a way to call functions in a C library, or more generally in an object library. It doesn't really matter that the original source code for that object library was C. If your environment has a capability like that, then that is natural. The only downside, and then the source of frustration, of course, is that whatever you do in your environment is going to be a very low-level affair, because you will have to live with for example, in .NET, it would be the pinvoke interface. In Java, it would be JNI, and in other languages, there are always these special sort of corners of those environments that deal with that very issue of basically calling into a shared library, sort of locating entry points in that shared library, having a convention about how to marshal arguments and things like that. And it ends up to be pretty messy and so forth, and a great source of frustration many times. And in many languages where people have solved this, I think if there can be a right way, the right way is, for example, with Python, where you typically have two a so-called low-level binding. And that low-level binding is really, you rarely, as a programmer in that language, such as Python, you will rarely use that binding, only if there isn't something provided in the high-level bindings or in the high-level interface, which really looks like Python. That low-level interface looks like C. So if you want to program in your language like C, then you use these low-level bindings. But most users, that's not the interface for most users. They want something that looks idiomatic, that looks like Python, that looks like R, that looks like Julia. You don't want sort of this low-level hodgepodge of stuff, and which is not good for most users anyway. So in where this problem of language bindings has been solved successfully, that is in all the examples that we have seen, is there's a high-level true API in that language or that environment, and then there are sort of mostly hidden away these low-level translation layers, so to speak, that make that calling happen. And Java is a sad story, because unfortunately there is only this low-level thing. Yes, there was, some people call it the object layer. This is sort of I wouldn't call it a high-level Java API, something that was basically stripped out of HDF View. So a higher level, an object level, call it that, Java API that, however, was written really in mind with the needs of a GUI application, in this case HDF View. And that, of course, is a very narrow or very biased way of looking at the needs of Java programmers with respect to HDF5. That if you do a Google search, there are other, in my opinion, more fortunate and more successful higher level Java interfaces for HDF5, for example, Bernd Rinn's JHDF5 and so forth, or to make it even more, in a way, language agnostic, HDFQL, for example, has a Java interface. It has sort of the same consistent interface for many languages. And so just reading through the struggles of this user, I really feel for him or her that they have to go through this, and they just want to solve problems. I mean, their domain problems, rather than sort of having to deal with all this idiosyncratic low-level craft. And it's unfortunate that, yeah, for some languages, the community sort of has found the energy and developed very nice solutions. But yeah, some languages are just sort of behind, and who knows. And then, of course, I said the second way is, of course, and we have seen an example at the most recent HUG event, is, for example, to say, forget about the HDF5C API. There is a file format specification. I can go straight to the bytes if I have a language, if I, in my language, know how to read bytes and starting at byte ranges, starting at certain offsets. Well, that's pretty much all you need. All you then need, in double quotes, all you then need to do is just understand the specification or the parts of the specification that are relevant to your type of HDF5 files, and then you can do whatever you want. You are not constrained by limitations with respect to multi-threading or other things, other limitations that the HDF5C API operates under. But then, of course, that's a much bigger ask to sort of digest large parts of the specification and so forth. But is it feasible? Absolutely. Look at JP Swinsky's work on H5 Coro. He has been very successful. I think, if I remember correctly, he said it took him about 6 weeks of work to pull this off. And yeah, he created something that gives him the performance that he needs, and there's no dependence whatsoever on the HDF5C API, and he can just focus on solving real problems. So yeah, all I can say is sorry. And yeah, we'll see. If I had to do something, my personal opinion, if I had to do something in Java at the moment, I would use probably HDFQL because, well, first of all, HDFQL has fantastic documentation. And I mean that also compared to our own documentation. I think the author did a tremendous job in documenting, providing plenty of examples, and so it's yeah, we learn from each other, and yeah, we should give credit where credit is due. Okay, I'm going to pause here and ask, are there any questions? No? Okay, good. There was one more posting, yeah, and this was, we talked about that in the past, and at that point it was just a suggestion. There was a user that was looking at an HDF5 file that was open in HDF view, and then when he tried to open it from another application and so forth, he could get these unable to open type errors. And then yeah, the solution is it was related to file locking. And in this case, it's sufficient to tell the library to basically not to attempt any kind of file locking by setting an environment variable. So if you work in Bash, for example, you would use export this, but then yeah, in your shell there's a similar set or whatever command, and that's it. And yeah, you can read up. I forgot 3-4 weeks ago maybe we talked about this in a little more detail. Okay, that was what was happening on the forum. Any other question? Otherwise, we have 2 minutes and I can quickly tell you something about something else. No? Okay, tips, tricks, and insights. Today is maybe more of an insight. We had the privilege to be, we, the HDF group, the privilege to be part of a team that won this year's R&D 100 award. And it is the so-called Mochi project. And I put the link in here. It's a collaboration between Argonne National Labs, Los Alamos, Carnegie Mellon, and the HDF group. And if you want to know more about Mochi, because unfortunately we don't have too much time to talk about it, and also Jerome is the guy, I'm not really competent to talk about Mochi. He gave a very nice introduction at the HUG 2021 event, and so there's a link to the YouTube video here. The background to all this is in a way that these guys noticed that, okay, we have these ever more complex scientific workflows where you have multi-physics simulations that have to share data, and the sharing is not always synchronous, it's rather asynchronous and so forth. So, and it all leads to that instead of having very monolithic, sort of very feature-rich data services, it's perhaps a good idea to create much more modular or composable, as they call it, data services and other building blocks like concurrency management or data structures such as key value stores and so forth, and then offer that in a nice, I call it a refined tool set for modern architectures. So architectures such as the sort of exascale systems coming up, perhaps also cloud-based architectures and so forth. And these use this as a toolkit for this new breed of very demanding distributed and parallel applications. And so I invite you to check that out if you are the author of such an application or such a system of applications. And I work with the Hermes project, for example, and we use Mochi, for example, for its RPC capabilities. And so if you have an application where you just use MPI because you have to exchange messages, well, if it's just messages, you might consider using RPC and so forth. And so Mochi does that as one of the services that you can combine or use to build applications. Anyway, enough about Mochi. If you haven't heard about it, check it out. I think it's definitely worth your time. And then just one more housekeeping. I think going forward, it's probably tiring to listen to me all the time. What I would like to do is I will ask colleagues, collaborators, and so forth, if anybody would like to sort of share their favorite hack, HDF hack trick in this series, I'll invite them and we'll set aside 15 minutes or however much time you need. And then if you want to share your experience, your insights as part of this forum, that would be wonderful. And time is up. My apologies. And thanks for coming, and come back next week. Bye.